You took this test. This is me going over the test, so you can watch this or fast forward or see which ones you got right or wrong. But this is my new way of trying to go over testing quizzes. You can always meet with me or go over it separately, but here it goes. What are the solutions to this? So we're going to have to divide both sides by 2/5. We get x is less than -4 divided by 2/5. And then x is less than -4 times the reciprocal. So x is less than -20 over 2, or x is less than -10. Well, you can't see it. There's a little bit there. So divide by the coefficient, and we do multiply by reciprocal, and we get it. So let's see, where is that? Oh, I guess it was less than or equal to. Good thing I checked my thing. So there you go. Answer is A. All right, what are the solutions to -5i is greater than 30? Well, we're going to solve it. So I'll divide both sides by -5. And that means I'm going to flip the sign, right? So cancels. A is greater than -6, but we have to flip the sign. So the answer is -6. All right, let's go to 3. On the average of 2 tests must be 94 or higher to get an A in class. Bryce got an 86 on the first test. Which inequality represents a score he must receive on his second test to get an A? Well, to get an average, you need to take 1, add it to the one we don't know, divide it by 2, and they want to get an A, so it must be 94 or higher. Okay. So putting it together, is there one that looks like that? Yeah. Okay. 94 or higher, D. All right, what's the graph of 2h plus 10, which is less than or equal to 14? Well, to find the solution, we're going to solve it first. So h must be less than or equal to 2. Here we go. Okay, we got to solve this guy. So we got 37 is less than or equal to 10 minus 3m, 3 times m minus 5. Okay, I keep slamming you guys to know about distribute the negative, so I'm going to distribute this negative to these two numbers. So I get 37 is less than or equal to 10 plus -3m plus 15, because a negative times a negative is a positive. I'm going to combine these two. So 37 is less than or equal to 25 plus -3m. Take away 25 from both sides. You get 12 is less than or equal to -3m. So to get m by itself, I'm going to divide by -3. So I get -4 is less than or equal to m. But this is a false. I need to flip the sign. -4 is greater than or equal to m. And if I reverse it the other way so I can see it better, m is equal to -4. M is less than or equal to -4, and that is right there. Boom. You might have taken this and turned it into that, but remember the m's there, so it's different. Okay, number 6. Which inequality is the same solution as the graph shown? Well, this says x must be less than -3. Okay. I'm going to solve this first one. It says -3 is greater than x, but that's the same as x is less than -3. So I found it. Boom, that was quick. Just gonna grab a sip of water. Number 7. The maximum capacity of a theater is 471 people. So far, 254 people have been seated. Right, inequality we solved to show the number of people, P, that can be still enter the theater. All right, so it's got a maximum capacity of 471. So that means we must stay below that, less than or equal to that. We know that I have 254 people plus an unknown amount, but it has to be less than this. So do we see that anywhere? Oh, there it is, C. Perfect. All right, we're solving this. So first thing I'm going to do is distribute. And then 2 squared is 4 plus 8. So we get 4c minus 20 is greater than 12. Add 20. Add 20. 4c is greater than 32. C is greater than 8. And we got D there. Awesome. Okay, which represents the solution to this? Okay, so I'm going to distribute first. We get 3x plus 12 is less than 9 plus 3x. Well, will 3x plus 12, well, I'm going to just subtract just to make it easy. Is 12 less than 9? No. Since there's no variables and this is false, sorry, you can't see, I'm zoom out. Since this is false, that means it's a no solution. Nothing will work. All right, we're going to solve this compound inequality over here. I guess I'll do it over here so we have more room. Negative 3 is less than or equal to 2c minus 6, which is less than or equal to 1. And there's a little shortcut we can do here. You can just do it to all 3 sides. Divide by 2. Okay, 1.5. 1.5 is less than C, which is less than 3.5, so that's B. Okay. Which graph represents the solution of those two? Well, I'm going to have to solve each. So it's an OR statement, so I know it's going to go away from each other. I just have to finish. All right. Just separate this. So I'm going to add 1 to both sides in the first part. And then I'm going to divide by negative 4. And this is false because I divided by a negative. So it's f is less than negative 2. Okay, so that's one of the answers. And then f is greater than 4, 1 divided by 3. So greater than 4, less than, aha, there we go. Boom. All right. All right, that's okay. All right. So we're going to solve each inequality. Just make sure you show your work. All right. Multiply both sides by negative 7 here. That will help. We get x minus 3 is less than or equal to negative 70. But since we multiply by negative 7, we have to flip the sign. Then we add 3. X is greater than or equal to negative 67. All right. Here we have to solve, so we'll take away 4 from all the sides. Then I'm going to divide everything by 2. All 3 things. Different colors you can see. And then I get negative 7, which is less than or equal to b, which is less than or equal to 8. Okay, this one I'm going to add 10. Get the absolute value by itself. Then I'm going to drop, drop, flip, kick. Drop, 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 flip, kick. I'm going to get x is less than 8. X is greater than negative 16. So less than 8, greater than a negative. So this must be an AND statement. All right, we know this is an OR. We'll add 4 to both sides here. We'll get y is greater than 6. Take away 1. Y is less than 4. And we know it's an OR. That was an easy one. Why does this inequality have all real numbers as solutions? Well, first thing is I'm going to solve it. And then you can see any number placed in 4x and then added by 4 and then take the absolute value of will always be greater than or equal to 0. Something like that. Or you can say absolute value will always be greater than negative, something like that. That's great arbitrary work. Okay, last two here in the extra credit. So write a compound inequality to show this graph. Should be easy. We have an and statement. We take our lowest number, -1, our highest number, 5. And because these are open, we're going to use less than. All right, it's recommended that the metal device be stored at temperature above 32 degrees Fahrenheit and below 70 degrees Fahrenheit. Write a compound inequality to represent all the acceptable storage temperatures. So we could say that temperature has to be greater than 32 and the temperature must be less than 70. You could have also written it as an and statement like so. Okay. So if a minus b is going to be greater than a plus b, what must true? The answer is D. B has to be negative because if b is negative, is a negative number, if b is a negative number, then negative b becomes positive b, and positive b becomes negative b. Right, so if you put a negative number in here, it becomes a. If you put a negative number in this, a minus b is greater than a plus b. If you put a negative number in, like a negative b in both places, this becomes a plus b, and that's going to be greater than a minus b. So you put negative numbers in, and then this will always be true because a plus b will always be greater than a minus b. Okay, cool. The students always have better explanations on that one where we can figure it out, but that's it.